idea how I know how this thing is starting. All right, well, this is going to be my every circuit, I guess, introduction tutorial, kind of, if you will. So you'll notice that on the screen, it's like set up in a breadboard style. You have the different nodes where they're connected to and that kind of thing, right? Now, we start off, and then really all we have on here is a ground symbol. So what I'd like to do is go ahead and do some basics. You can see up in the top, it shows you which environment you're running in. You can set up workspace, for example. So there's like even pull downs from different community people that have posted things on there and such. Over here is your profile. You can even go into like settings. One other thing here, this probably everybody has like this, where it's standard style. You can go in and change that. Let's keep it simple. So I'm going to start off with just like really just a series circuit. So we're going to need a voltage source, right? And two resistors. So our voltage source, now notice, we got a plus side, a minus side, right? So let's go and set that. Oh, my bad. Let me get a little more proficient at the mouse here. We'll drag our voltage source down. We'll pick a resistor. I'm going to just make a very simple series circuit here. Right. Let's get that lined up. So now you've got your components. Now one thing I'm going to highlight, notice, okay, this is a DC supply, right? So you got a plus side and a minus side. So it'd be like your DC power supply you had set up at in the bench at in the lab. Okay, so on the plus side, think of that as like your red lead, and on the minus side, that's your black lead. Okay, these both sides have to be connected. So we'll attach that to our input resistor here, R1 or RS, right, source resistor. And then we'll pick this side and join the nodes, right? And this will be our load resistor. And then we'll complete the path. Oh, look, ground's all by his little self. He's lonely. So let me grab this correctly. Oh, good Lord. Yeah, bear with me. The last time I used a circuit simulator was probably about 1998. I worked for a company called KLA 10 Core, and we used something called P-Spice. I mean, this was a DOS-based system. You know, it's basically the predecessor. Some of you have digital. I know Bob's cranking out and having to use LT Spice. Well, P-Spice was the beginning DOS version before anything was Windows related. And trust me, this is like about 1,000 times easier to use than that was. Anyway, I digress. So here we have a simple series circuit, right? Two 1Ks. We got a 1 volt. We can change that. Let's give it, right, we'll go in there and change our parameters. So adjust. How much voltage would we like to make it? I'm gonna, let's make it a, oh, I don't know, 12 volts power supply, kind of standard, right? Now it's not doing anything because we have not turned it on. So here we got two little icons down on the bottom here, right? See how it says run transient? Well, ta-da! So now you've got conventional flow, right? The little green dots running around, and a conventional, you know, it's going from plus to minus. So we can see that it's a series circuit. So if we were to do the math, you know, use basic Ohm's law, right? 2K is the total resistance. We got 12 volts. And yes, indeed, there's 6 milliamps. Now, the cool thing you notice, all right, up on the side here, okay, 12 volts is coming in. And notice that's highlighted right here. You got 6 volts. Well, it should be an even split, right? Kirchhoff's voltage law, 6 volts, 6 volts. You notice down on the bottom here on the return path, it's 0 volts, which would be what we would expect to see. We can verify it. We got a little tool here called the voltmeter, right? We can bring him over, and we can even connect him into the circuit if we like so. Ta-da! And again, we're gonna run our transient. And in this case, I picked show waveform. Well, hopefully in a DC supply, we don't have a waveform, right? And pretty much, oh, what's it showing me? Well, if you see, notice how it's blue here. Well, what have I picked? I picked blue. But if I go and pick like that, see now it's green. Oh, look at that. So now what it's highlighting, it's showing me, it's showing me that I clicked too much. Rewind, run again. So what this thing will do is, notice how, okay, the blue is still highlighted, and yes, there's 0 volts on the return, and the green's highlighted, but let's take a look here. Oh, look, we'll add that as well. See, it's color based, okay? So on one side, it's showing you that at this node right here, you have 6 volts, and then at the other, you have 0 volts. Now, if I wanted to, see down here, we have a little camera icon. I could take a screenshot of this if I wanted to. But that's pretty much, you know, this is really basic, really straightforward, right? Let's get rid of him. I really don't need that. All right, so in the garbage can he goes. So let's try adding one more. We're gonna make this guy, oops, yeah, see, I'm not all that great at this myself, but oh my God. I'll add him in there, okay. And now we'll make it a series parallel circuit. Oop. That's what happens when you get crazy and clicking too often. Well, we do that. Now, we'll attach that in there like that. Oh, let's go ahead and change our values, okay. I'm gonna make the series resistor 10K. And then I'm gonna make each corresponding one down here. Oh, no, I don't want 10K. My bad, hold on. We're gonna make him 5K. And then this one, we'll make him a 10K. And you can use the little dial and spin it around quickly. And then for fine tuning, you know, you can step up or down with little plus minus signs, but those are a little slow. And then we'll make the other one 10K as well. And you do the math, you'll kind of, oh, good Lord. You'll kind of see why I did that. All right. So what are 2 10Ks in parallel? Well, they come out to 5K. Are we sure about that? I'm pretty sure, but we can use this guy to verify that, right? And this is an ohm meter. So they put in pretty much all the little doodads for us, right? We can look, let's run it. Yeah, see. And there we have it. So now we see, you know, pretty even split. We got series parallel, so of course, you know, the current's going to be different, but I made them even, so you'd expect it to be the same there, right? Excuse me. Okay, so pretty basic stuff. Again, like I say, when you connect this in, remember that your DC supply here has both 2 nodes, right? Plus and minus. Both have to go somewhere. Otherwise, nothing is going to happen. So let's go ahead and change this device. We're going to go to an AC signal. Notice that, right? We can make the frequency, oh, I don't know. Let's pick 10 kilohertz just for fun. Oh, God. $10 kilohertz. Change our amplitude. I don't know. We'll give it 4 volts, right? No phase deviation. We can give it a DC offset too if we want, right? So now notice there's something a little different. Now we've got 2 triangles down here. One says to run a transient, one says to run AC. Now notice I don't really have anything highlighted except this blue guy here. So if I were to run transient, really all I'm going to see is the input voltage, right? So I set 4 volts peak to peak, and there you have it, two up, 2 down, and we're running along at 10 kilohertz, all right? Let's rewind that. Now, an interesting thing with this is, all right, if you've gone through the chapter, chapter 34, we're starting to run into doing logs and bode plots. And bode plot shows you the overall response of a given circuit, right? Well, this little guy will, oh, look at that. It will run bode plots for us on the fly. Now notice, all right, now we're in AC, notice these points here. Well, those are probe points that you can highlight, right? See, so let's go ahead and do those. We got orange there, green there, and blue there. All right. And we have our circuit. And now, let's go and run. And you'll see, okay, so now we got the input one, that's our orange signal. We got the output one here is a green. And then the blue is running down there. Of course, there's nothing happening on the return, right? Well, that's what you would kind of expect to see. So now you look, and there's a bode plot of all those points as well. So it's highlighting that. We can have a highlight this, see how it changes the color with me. There's your blue bode plot response. Now notice on the negative side that it actually jumped down to a -1 kilodecibels. And there's a response across the frequencies, right? Pretty much flat line. Well, it's a return line. But notice on here, it's a 0 decibel response, or here is a 0 decibel response. That's because we're just using resistors. There is no reactance, if you will. Now, if we were to change some of these components, like let's say this guy, right? Let's throw him in a trash can. But now let's pick something different, like a capacitor. Ooh. So we'll go, oh, pardon me. So we'll throw that in there. Oh. And now we have a capacitor. So essentially we have now an RC circuit, right? So let's run our AC now. Our decibel response on the orange is that, but look at the green. See, now we have a sweep. So essentially what kind of circuit we have at this point, right? It's rejecting, if you notice, down in the 100 hertz range, it's going to reject those low frequency signals, but it's going to let pass the high frequency ones. But now if we change the, oh my God. If we change the capacitor value, right, kind of neat, we could go, oh my God. Oh, like I said, we change this capacitor value. Oh, good God, with this thing. Really, that's my mouse. I don't have like the best equipment set up at home, but it works for the most part for me. But yeah, let's say 200 nanofarads. So now we've got this going on. Now let's see what our, oh, look, our bode plot did change. See, so cool thing, on the one arrow, it basically will give you your bode pot or your overall response of your circuit, right? Go back. And then when we run AC, it'll show you what your signal, oh yeah, notice right, we changed our capacitor value and look how much smaller my signal became. And it's kind of direct relational. So when you're doing these, this is the kind of thing you're going to be looking for. And I mean, we can do this all day long, but really everything is double-ended, right? Everything, just like in labs, you know, you got your meters, right? So we got a voltmeter, an ammeter, an ohm meter, you got a ground, an inductor, capacitor, resistors. We might get more into this a little later on. We can simulate, I don't know if anybody was paying attention, but on some of the transistor models or like the amplifier models, they give you something called like a T or a pi approximation, and we can use these, okay, like this, these sources, and then we can go through and approximate our transistor, where you wouldn't actually have the transistor symbol set up. We would have the pi variation set up. So, and this would give us the same, I mean, it works the same precise way. Well, let's run through our symbols, right? We got switches, and okay, there's an op amp, which we'll be getting into later. A transformer, you got your potentiometer, right, with values for it. Push button switches. You got a current control current source, which is a type of switch, right? You got lumens, lamps, right? DC motor that we could hook up. Maybe we'll get into that in a little later. But even for your digital applications, you know, you've got an SR flip-flop, right? A D latch in there for you, a T latch, JK flip-flops, even a 7-segment display. You know, you got your decoders, a counter. There's our 555 timer. You got an ADC, which is an analog to a digital conversion, and DAC, which is a digital analog conversion. We won't be covering that, of course, in this class. We might do some 555 timer stuff. And you have the corresponding gates, right? So there's like your AND and OR. You got an inverter, right? Your NAND, your NOR, exclusive OR, exclusive NOR, you know, that type of thing. We also have, yeah, logic train. Yeah, we won't get into that. Logic source, but that's it, all digital. RN, we're going to stick like here, there's an LED. It's basically, this is know your symbols, right? And so LED, standard diode, there you got the Zener, and here we got BJTs, right, bipolar transistor, the MPN style, which is what we've been normally using, like the 2N3904. And then the PNP style, you got MOSFETs, and we could configure those as JFETs as well. We just have to watch our parameters. But if anything, we can always approximate our, I might even get that out for some of the labs coming up. We can approximate what we have going on by these sources, okay, where we would still have a supply hooked in with it, but inside of that, we would have these sources instead of having the actual device. So we would be simulating the device, if you will. But yeah, when you go through all of these, let's try here. Let's get rid of all that. I mean, it's a fairly simple thing to set up, really. What I would do is I would look at the lab and see, okay, what am I going to need for my lab, right? So if you need voltage sources, go ahead and set that off, right? You need a certain amount of resistors, even to the point, okay, I'm going to need an NPN transistor. So if I were to look through, even to the point where I set up, and I'm just doing this on the fly, right? But let's say, what are our parameters on him? So there's we see our beta. Beta's set at 100. It's like I can live with that. Our saturation current, we can change that as well. And this is how you would set it up basically to match, whatever device you're working with, you know, based on the spec sheets. So those would be your parameters. The reason I use this is basically because of the ease in use with the drag and drop capabilities like this. It's real nice. I don't know. Oop. I mean, it's fairly smooth. You know, you don't have to worry about placement. You don't have to identify nodes. A lot of times with SPICE programs, you have to go through and make sure your nodes are identified and whatnot. Here, we're just simply dragging and placing, which is really nice. And, you know, your node connection's fairly straightforward. All right, so that's our emitter side, right? There's our base side of the transistor. And here's our collector. So I'm just setting up a simple transistor circuit, if you will. All right, now I got everything but my voltage source. Now again, I'm going to point out, it's like, remember, be very aware of your positive and negative here. If I just drag this in and placed it like this, I would be putting my negative side into that, right? I don't want that. So let's rotate it. Okay, I'm going to basically connect my positive into this node. And what are we missing? This guy, right? And without this circuit, I mean, if, all right, let's look. If I try to run it, what's happening? Absolutely nothing. Notice all the 0 amp symbols everywhere, okay? This is where current's gonna flow. Well, guess what? No current is flowing at the moment, so there's nothing happening in that circuit. But now I have a path to ground, just like in lab. See, now look, everything's flowing, okay? We got that going on there. Of course, I'm only using a 1-volt source, right? So that's not gonna work very well. Plus, I'm not balanced at all. So let's change some values here. Give us a more balanced style circuit. We'll put 100K on the base side. I'm just making this up on the fly, so I don't know. We'll see how it works. If it works, it's great. If it doesn't, oh well. You can always change it. No biggie. 5K there, right? And let's go ahead and step our voltage up a little here. And let's give it, oh, heck with it, right? We'll go with something odd like 13 volts. So here's our circuit running. I got a 13-volt supply. It says 900 microamps, 0.9 milliamps, right? Look across it, and and then you can actually even do the math, make sure everything balances out. I mean, if we were to go through and let's even check something here. All right, remember BVE, which should be VEV. Why, look at that, 719 millivolts, which is 0.7 volts. So that shows you that this works. Our transistor is balanced. We got 0.7 volts. Putting that into forward bias, yeah, we can insert a voltmeter in there in different ways, but like I say, it's fairly straightforward. Just drag and drop your components, make sure everything is completed as far as paths to ground. I mean, I can share this, right? But I don't use Twitter, and none of us are Facebook friends. But if I want to go through and take a snapshot of this, I got this here, right? Now it's asking me, okay, what style you want? It depends. The black screen will take up more memory. The white screen will just be like a straightforward schematic, So I'll pick that one. For me, it saves down in here. I can go ahead and open that bad boy, right? And there it is in my, I don't even know what the heck this is, the Microsoft Photos thingy. And then I can go ahead and edit that if I wanted to as well. And if anything, though, I can save it and give it even a name besides Circuit 2. I can put my name on it if I wanted to, right? But there's my circuit. It shows, hey, it's running. I got my values on there and things like that. Hopefully, it's everything that, you know, for everybody. If this is, if this helps, I hope it does. If not, we'll run over some more. But that's what I really have for now. I mean, it's great. Like I say, it's fairly straightforward. Drag and drop your components, change your values like in your labs, and put them, you know, and you can put your meters wherever you need them to be, that kind of thing. And again, I know, it's been difficult. I have never ever in my life ever hosted online meetings before. I think I've done Skype maybe 3 whole times in my whole life. My video training has been Facebook meeting, doing like video calls and stuff like that. I don't know if anybody's familiar with that, but that's about the extent of my video online hosting and all that. So I'm glad everybody's been patient so far, and I know it's been kind of rough out there and whatnot with all these changes, but I do like this simulator a lot. I think as far as ease of use, it's a lot easier to use than LT Spice and some of the other simulators out there. And again, it works on just about every platform without much of a problem. I mean, notice up in the top there, you got the app. What I usually do is I shortcutted that. I I actually have a little internet shortcut that I guess I could rename, but that's what I did with it. But that's all I have for now. If anybody, again, if you have any questions, you know, get a hold of me and we'll work it out. Okay. All right. Signing up.